I shut the door?
Please do. Yes, please. All right, as we're looking at section 8, division property of exponents. Okay? For the sake of it, slide over to page 28, and let's just give you an example of two things, and this will make perfect sense to you. If I say x cubed, what does that mean? Remind me. X times x times x, right? And if I say x to the 5th, what's that mean?
X times x.
X times x times x times x times x. True? Everything there is perfectly normal. Now, if there's factors in the top and factors in the bottom, they're identical, what have we done forever and ever and ever? We cancel them, okay? Boom, boom, boom. Things cancel to what? To 1, right? So what's left?
2x.
How many x's is this? Just x times x, which is x squared. What about the top? 1. Does that make sense? Now let's do one that's bigger on the top. A to the 4th. Let's make that a to the 14th over a squared. Do you really want to write a, that's 9, a, yeah, I know, a, over a. I wrote 14 a's on the top, 2 on the bottom. How many cancel? How many are left? 12, right? Okay, now this is extremely tedious. This will take us forever if we do our homework this way. So what's the pattern? Grace? Just subtract. How do you know where the exponent ends up? The top one ended up on the bottom one ended up on the top. Okay, wherever there's a greater exponent, good, that's where your variable ends up. What if it ends up on the bottom, then what do you put in the top? A 1. Does this make perfect sense? Okay, let's look then. When you divide numbers with the same base, you blank the exponents. What do I put? Good morning, Haley. I subtract. Very good. So, let's just knock through this quickly. 2 to the 7th, 2 to the 5th. Do they have the same exponents? Where is it bigger? Top. So, 7 minus 5 obviously is 2. Our answer is 2 squared. Can you put 4? Yes. Doesn't matter. Not really. I threw the second one on there because last year I had some people who struggled with negatives. I have to ask myself the question, which is bigger, -3 or -5? -3 is bigger. So it's going to end up where? On the top. So watch. What is -3 minus -5? -3 minus a minus becomes a plus. So it's m squared. Now, Noah, we've done that. You could have done this a different way. You could have said, oh, what if we thought of that as m to the 5th on the top? Because remember, negatives in the bottom become what? Positive on the top. And negatives in the top become? Is it the same thing? Do you still get m squared? Is this easier in concept to feel out than this one? Yes. But you can do it this way. I just want to show you it works either way. Yeah, Katie.
Wouldn't it be 1 over m squared?
No, because the larger one's in the top. The larger one is m to the -3.
Oh, okay.
So that is in the top. So whatever's the larger, if the larger's in the top, you end up in the top. If the larger's in the bottom, you end up in the bottom.
Okay.
That make sense?
Yeah.
All right, moving on. 5 to the 3rd over 5 to the 6th, this is a bad box, equals 5 to the box. -3. How'd you get that, Josh? Sure, you just subtract 3 from 6. Do you think I'm going to let us write our answers like that unless it forces us to? How would I rather have that answer? A little louder? 5 to the 3rd, underneath 1, right? Okay. But if they forced you to make it a box, then you've got to do the subtraction from the top. All right, multiple problem over here. Luke, you feel okay with these? All right, look at the 3's. Where are they bigger?
Bottom.
So 3 to the what on the bottom?
Third.
Good. Excellent. Going back from there, Zach, M's. Where are they bigger?
There's M to the fourth on the bottom.
On the bottom, okay. And going over from there, Tara, are you okay on these?
Yeah.
T's, where are they bigger? Okay. T to the what? Careful. 6 minus negative 5. See that? So T to the 11th. Are you guys know that 3 cubed is 27? We okay there? And M to the 4th. Hey, in general, if the book ever does a T, and I brought this up before, if the book ever does a T like this, change it to a capital T. Because the temptation is you get a little sloppy and all of a sudden it becomes a plus. And then your problem changes. So just a little comment there. Always work with the capitals. All right, sliding down. Here's the basic notes that I put in. When simplifying scientific notation with division, divide the constant term, then use the powers rule and the base to simplify the base 10. So it's really 2 parts. So if you have your calculators, take them out. I'm going to circle the first part here. 6.8 divided by 1.3. Take your calculator, divide that for me. 6.8 divided by 1.3. I get the same thing, 5.23. Times 10, and now I do the power rule. 12 and 8. Now in this case, Justin, scientific notation says it has to end up in the top. Right? So you have to subtract the top minus the bottom. Top minus the bottom in this case gives us an exponent of 12 minus 8, 4, right? Look at the next one. Take your calculator, 4.65 divided by 3.1, it's 1.5. Times 10 to the negative 8 minus 12. If it helps to write that, go ahead and write that. It's fine. I'm sorry, Josh, I didn't hear you. Negative 20. Very good. So far, so good? All right, flipper. It says raising a quotient to a power. What's a quotient? Okay. In a fraction of some sort. So all of these are quotients. They're division problems. When you raise a quotient to a power, you raise both the numerator and the denominator. And then there's a caveat. If you have a negative power, then take the reciprocal and use the positive. We'll deal with that in a sec. That's kind of a special case. What do you think we should do? Simplify first and then raise it to the power, or raise it to the power and then simplify? Yeah, so what's 3 over 9? 1/3. Square the top. 1 squared, 3 squared. 1 squared is 1, 3 squared is 9. Simplify first, then raise them to the powers. All right, part B. 5 cubed, x cubed, y cubed over, help me here. Do you remember from the other day? A power to a power. That's the question. Do we add or do we multiply? That's the question. We multiply because it's really z to the 4th times z to the 4th times z to the 4th. How many z's do I have? 12 of them. So multiply z to the 12th. Without your calculator, does anyone know what 5 times 5 times 5 is? Sydney? 125. All right, our general rule of thumb, if it's less than 1,000, write the number. If it's greater than 1,000, leave it as a number to a power. How did I get this 12 again? Power to a power, we what? multiply. All right. Now, the negative exponent thing. If you have a negative exponent, what was in the top does what? Goes to the bottom, and what was on the bottom goes to the top. So it would make sense if we have a fraction to a negative exponent. This is kind of a new idea. What we do is we take the reciprocal to the positive exponent. That's a new idea there, so we need to make sure we're doing it. So a fraction to a negative is the positive exponent with the reciprocal. So now we have 9 cubed over 5 cubed. Now let's do this in our heads. No calculator here. What's 9 times 9? 81. Okay, now you got to think in your heads. So everyone take 10 seconds here. 81 times 9. Don't say it. 81 times 9. Think of it in your head. Think 8 times 9, 1 times 9. 81 times 9. What do we got? Luke? 729. Good. And someone else, 5 cubed. Not Sydney. She already got that one. Luke, John? 125. All right. So, another similar one. I'll call this C2. 2/3 to the negative 2. 3 over 2 to the second, which is 3 squared over 2 squared, which is
9 over 8.
Okay? So really quick, really simple, all you're going to do here, Haley, is just flip and do the power thing. That's it. All right, here we go. D. What do you think? Power to the power rule first or simplify first? Simplify first. Make it easier on yourself. X to the 4th, x to the 9th. What did we learn on the first page? Where is it bigger? Bottom. So where's it going to end up? Bottom. How do I get a 5 there? What's my reasoning? I'm just subtracting. All right. What's 1 cubed? Over x to the 5th cubed. Well, obviously 1 cubed is 1. And once again, now I have this power to a power. Noah, are you comfortable with this idea? X to the 5th times x to the 5th times x to the 5th is x to the... Well, we got 5 times 3. So just x to the 15th. Versus 5 times 3 here, which is 125. Big difference there as you're looking at the 2. But there you go. Is division doable? Yes, Josh?
If you had like a negative on top or whatever, and a positive on top, basically.
A negative on top, like x to the negative 3,
Yeah.
and a positive on the bottom, like x to the 10th.
But yeah, pretty much we just sort of
Where is it bigger?
bottom.
It's bigger on the bottom. So it's going to go to the bottom, and it's going to become 10 minus negative 3. This is going to be 10 minus negative 3. Minus a minus is a plus, so that'll be 10 to the 13th. Yeah, wherever it's bigger, that's where it goes. So, good question. All right, so 1 to 35 odd, pretty short. Remember, copy the problem down. In many cases, there won't be any work needed. So you can just write your answer. If you have a fraction, use 2 lines to write it, and we should be in good shape there.